Welcome to Winchester Cafe Sci Online, and a special welcome to those joining us for the first time. A recording of this talk will be posted on our YouTube channel, where you'll find recordings of all our online talks, and I'll put details of that in the chat. It would help us reach a wider audience if you could subscribe to our channel as well. And you can also find the links on our website. If you enjoyed tonight's talk and you're not on our mailing list, you can sign up for it there to be notified about future talks. After tonight's talk, we'll probably go straight into the Q&A, so please put any questions you have into the chat and I'll read them out or invite you to, and that includes our viewers on YouTube who can also put questions in the chat there. Tonight's speaker was elected Fellow of the Royal Society in 2014 for his fundamental contributions to understanding the history of life, particularly biodiversity fluctuations through time. He's fascinated by the transformation of paleobiology from a speculative subject to testable science and led one of these discoveries, how to determine the colour of dinosaurs, rated as one of the top scientific discoveries of the 2010s. He works with fossils and rocks to interpret ancient environments, especially around the end Permian mass extinction, the greatest loss of life on Earth some 250 million years ago. He also works with fossils to build evolutionary trees and use them to date major events and rates and patterns of evolution, so helping us understand why some groups of animals are more successful than others. He's currently working on the Triassic, the time during which life recovered from the end Permian mass extinction and when modern ecosystems arose. This was a time of arms races between major groups, and dinosaurs won. He's written some 400 scientific papers and more than 50 books on a broad range of paleontological topics. He's supervised more than 70 PhD students and was founder of the Bristol MSc in paleobiology, which has welcomed 400 students since its foundation in 1996. His new book, the subject of tonight's talk, brings us a new visual guide to the world of the dinosaurs, showing how rapid advances in technology and amazing new fossil finds have changed the way we see dinosaurs forever. I'm pleased to announce that P&G Wells, the local bookseller in Winchester, are offering a 10% discount for online purchases, and I'll put the link for that in the chat. With that, please welcome Professor Mike Benton.
Thank you very much. Thank you for the wonderful introduction, William. That's very kind. Thank you all for coming. I shall talk for about 40 minutes. I'll switch on to the slides in a second, and I will try to fill you in a little bit more on some of the topics that William has already introduced. So here we are. The first attempt to visualize dinosaurs is shown here. Some of you may have visited the Crystal Palace display. It's in the park at Crystal Palace. I won't go into the history of why the place is called Crystal Palace in South London, nor indeed in great detail why these life-size dinosaurs are there. What you see are a remarkable array of dinosaurs shown as they were conceived by Richard Owen, this rather beady looking chap in the middle, who was one of the great Victorian scientists. And he worked with Waterhouse Hawkins, who was the artist who made the sculptures. They're built of iron and concrete, with pure Victoriana. Of course, we look at them now and we think, well, these are ridiculous. They're completely incorrect. At the time, they created a huge stir. This is 1853, 1854, and this was the first episode of Dinomania. But what it illustrated was that there's an insatiable desire by the public to understand what these ancient creatures looked like. Dinosaurs at the top of the list, but obviously all kinds of other prehistoric creatures. And they were supported at the time by illustrations and souvenirs and so on. And as we look at them then, it is easy to mock them or easy to say how silly. But in the day, that was the best that Owen and Waterhouse Hawkins could do based upon the evidence that they had. We've obviously got a very different picture of what dinosaurs look like. And I must be careful not to seem as if this is the final picture, because I expect in another 150 years, people might revise the opinion further. But I hope what I can show you is based more on evidence than Owen had shown a number of years ago. Now, we go back 25 years. So we're racing forward from Owen, but we're going back 25 years to the story begins, my story begins in 1996 at a meeting of the Society of Vertebrate Paleontology in New York at the American Museum of Natural History, which some of you may have visited. And something was afoot. I was a relatively young person then. I wasn't in on what was going on, but there was a buzz, an unusual buzz in the corridors. And it was caused by this article that appeared in the New York Times during the course of the meeting, October 1996, so almost exactly 25 years ago. And the journalist, Malcolm Brown, was writing here about a feathered dinosaur. Now, of course, now we're quite used to the idea that dinosaurs had feathers, but back in 1996, we absolutely were not. If you asked any expert who's got feathers, they would say birds. And if you then ask, well, could dinosaurs have feathers? Almost certainly any paleontologist worth his salt would have said, certainly not. Only birds have got feathers. Dinosaurs can't. Nonetheless, here is a report. And he mentions, the journalist mentions Dr. Philip Currie, a name that some of you may have heard, very eminent dinosaur paleontologist, still active in Canada. And he had seen the thing and he was assuring the journalist what it was. And yet this is an unusual report because it isn't based on an official paper or a poster or any formal presentation at the meeting. This was based on hints and tips and rumors that the journalists had picked up in the corridors of the museum. And indeed, what he had heard was that there was a Chinese paleontologist called Peiji Chen from the Nanjing Institute of Paleontology who was at the meeting. And I remember meeting him, and this was quite extraordinary back in 1996 because China was just coming out of having been a very closed country. And he had photographs of this extraordinary specimen, which I show here on the slide. And you'll be able to work out what it is pretty much. It's a small two-legged dinosaur. You can see quite a big head on the right and smallish body, longish hind legs, quite short arms. There are traces of black in the rib cage, some remnants of the internal organs. But what was particularly intriguing was all the way along the back and down the tail were these tufts of whiskery type things. And Chen was asking people, could these be feathers or are they something else? What are they? And he was pursued by journalists as well as by paleontologists. So just note, fix that thing in your mind. But as Phil Currie looked at it, something was clicking in his mind because a few weeks earlier, he had been in Beijing, one of the first Western paleontologists to go there. And he was aware of the publication of a paper in Chinese, in the Chinese language, by two authors called Ji. And in English, the translation of the title of their paper was on the discovery of the earliest bird fossil in China, Sinosauropteryx, new genus, and the origin of birds. And this was published then in the Chinese language in this journal called Chinese Geology, 3 pages only, as you see, 4 pages. And there's a bit of the English translation that came out later showing that this person is very definitely calling Sinosauropteryx a bird. Here is the Beijing specimen that they used, and how they could call it a bird when it's got such tiny little short arms, obviously couldn't fly, I don't know. But presumably they were confirming that the feathers, the so-called, these whiskery things all along the back and the tail, actually were feathers, and if it has feathers, according to them, it absolutely has to be a bird. This was all happening then in October, and the two sets of events were kind of going on in parallel, it seems. But what was this all about? And you might have spotted something about those pictures. 2 years later, nonetheless, Chen published his paper in Nature, in the English language. Nature is a very high-profile journal, as many of you will know. This is a way to get the message to lots of people all around the world. And in that paper, he described the Nanjing specimen. He couldn't call it anything new. He realized it was the same genus and species as had already been described by G and G in 1996, so you can't give it another name. So he, in his Nature paper, had to use the existing name, of course, but this was an opportunity to show the world with full color and better illustrations what was going on. But let's just have a look. These two specimens, what are they? Here is the Beijing one, which is officially the holotype of the genus and species Sinosauropteryx prima. Here is the Nanjing specimen. And look at them. They look very similar, don't they? In fact, they are one and the same specimen. And technically what we call this is part and counterpart. So some very smart fossil collector in China had obviously got his hands on this thing, split it open, noticed, oh my goodness, it's split neatly down the middle, and we have a beautiful impression of this little dinosaur on each side. I'll go and sell each bit as a separate specimen, which is what he did. And nobody will admit how much they paid. So the Beijing Geological Museum has got the specimen on the right. The Nanjing Paleontology Museum has got the specimen on the left. And they're probably a bit cross about it, but there we are. That's how it panned out. And this, more importantly, was the first sight that the world had ever had of a feathered dinosaur, 25 years ago exactly this month. And since then, a huge amount has been found. And I'm going to talk a little bit about that in a second, but just to put this in context, how important were these discoveries? And the answer to that is really important, because the knowledge we had in 1996 had not advanced very much since the days of Owen and Huxley and Darwin. And so Owen was the older man, Huxley the younger. They were enemies pretty much in life, but they were both equally eminent paleontologists in Victorian England. And Huxley famously was Darwin's supporter. Owen was a sort of reluctant anti-evolutionist. And they argued about all of that. But of course, Huxley was very excited when this specimen was discovered in 1861. So we're going back again to Victorian times. And this is Archaeopteryx from Germany. And there are a number of specimens now. In 1861, just the one, and then subsequently another 10 or so have been found. Very complete, as you can see. And not only have you got the skeleton, the bones, but you've also got feathers. And there are paired feathers going down the tail, and there are obviously all of the wing feathers, the flight feathers on the wings as well. And Huxley famously said, this is a dinosaur in bird's clothing. And he very explicitly said, this is a wonderful intermediate fossil. If you're looking for evidence of evolution, he said, Darwin had published his Origin of Species only in 1859, so the timing could not have been better. 2 years later, we get this spectacular fossil. What more could you ask for as a kind of intermediate between reptiles and birds? But things didn't change much since 1861, all the way through to the 1990s. What we had in terms of our knowledge of the origin and evolution of birds was pretty much a bunch of dinosaurs, Archaeopteryx, several specimens, all of them very beautiful, and then modern birds and their ancestors back to about 75 million years ago. And there was quite a long time gap, both below Archaeopteryx, i.e. between dinosaurs and Archaeopteryx, and between Archaeopteryx and modern type birds. And these were the gaps that the Chinese fossils were able to fill. So just to give you an insight into what the localities look like, what this part of China looks like. So first of all, on the map, Beijing is shown with the little red star. If anybody has been there, you'll be aware that China is an enormous country. And we're visiting Liaoning province, which is just to the east, northeast. And although it doesn't look far on the map, that's about 500 miles. So it's a very full day's drive to get from Beijing into Liaoning province. And we first went there, a group from Bristol University, back in 2007. So this is long after the first bird and feathered dinosaur discoveries. But by then it was much easier to visit and travel around, and we were met with very great friendliness and have had great collaborations ever since. So here's this one of many localities called Sihetun. And what you can see in the photograph, there's a photograph on the right showing the natural appearance of the rocks. This has been quarried out. and the rocks are layered, and within these layers, they're full of fossils. And indeed, these are the deposits of ancient lakes. So some of you may have vague memories of varves in lakes, regular annual deposition of a few millimeters of sediment, et cetera, et cetera. Yes, that's what you are looking at. And of course, this stack of sediments probably then represents thousands and thousands of years. And they're quite iron stained in places. And in fact, they're full of volcanic ash. And it seems to be that there was a lot of volcanism going on at the time, and the volcanic ash was falling and mixing with the mud. And to some extent, the acidic ash helped to preserve the fossils. And there's even a museum in Sihetun Quarry, as you can see in the left-hand photograph. And the fossils are hugely diverse and abundant. I'm only going to concentrate on the birds and the dinosaurs, but there's a great list of other plants and animals shown here, which are typical of the lakes of the early Cretaceous, 100 plus 125 million years ago, something like that. And the Jehol is the regional name, and it's the rocks are sometimes called the Jehol group of rocks. And indeed, here is the first feathered dinosaur, Sinosauropteryx, and one that will pop up throughout my talk. And this was the first of many. And at the time it was published, there was considerable confusion, as I've already shown, as well as a great deal of argument about what it meant. Huxley would have gone right to the point, but G&G, remember, called it a bird. Chen and colleagues quite correctly called it a dinosaur. It is a dinosaur. It's a close relative of Compsognathus, which is a small flesh-eating dinosaur, not so close to the origin of birds, actually, some distance away. So that if these bristles really are feathers, this is suggesting a lot of dinosaurs had feathers. Here in more close-up on the right is an image of the vertebrae of the tail, slightly pinkish in the rock, and these regular bunches of parallel strands, irregular strands coming off at the side. Could they be feathers? Or as the critics said, maybe they're just shredded skin. They're nothing in particular. However, the shredded skin brigade had to rather backtrack when more and more specimens came to light. 2 years later, Caudipteryx with an extraordinary array of feathers, the small bristles all over its body, but notice it's got very elaborate contour feathers or pennate feathers, as they are called, with a central quill and branching barbs on each side. And it has these very elaborate feathers on the tail and on its little embryonic wings. And really nobody could deny that these really are feathers. And here are some of them in the bottom photograph. 2 years later, Microraptor. And I remember living through this every few weeks, every few months, another amazing discovery. And by this point, the Chinese colleagues had realized, get these things published in English, get them out in the international scientific journals. Don't hide them away in your own local little Chinese journal where people won't see them. And Microraptor gave a hint of something else that was not expected. Not only could dinosaurs have feathers, and indeed different kinds of feathers, they could also show different and unexpected modes of flight. Notice this thing has got 4 wings. Wings on the arms and wings on the legs. We'll come back to that. And at the same time, and even before the dinosaurs, people had already found quite a lot of birds. And I mentioned Confucius ornis coming from Sihetun Quarry. It's also known from many, many other localities, and now there are probably many more than 3,000 specimens. So whereas we used to get terribly excited about the small number, the dozen or so specimens of Archaeopteryx, now we have thousands of birds of similar high quality. And the first result of all this acquisition of new information in really very quickly in the last 25 years has been many, many species, 50 or more species of feathered dinosaurs, 50 species of birds. These have really filled up those gaps that Huxley would have noted, both below Archaeopteryx, the feathered dinosaurs, and above Archaeopteryx in the evolutionary tree. And not only that, it's allowed us to study the acquisition of bird traits, unique bird features, So until these fossils were found, we used to say, well, of course, Archaeopteryx, as well as modern birds, share something like 30 unique bird traits. And for ornithologists, this is a really important aspect of evolution. We want to understand why birds are so special. They're immensely successful. 10,000 species on Earth, they do what they do, which is flight, of course, remarkably well. And their whole body is adapted specially for flight. And yet it now turns out nearly all of these unique bird-like features had already been acquired by dinosaurs on the way to being birds. So it's filled out the knowledge, it's given us a great deal of information about the acquisition of the unique features that birds have. And the sketches across the top show that it's also allowed us to study the evolution of the wing. There's Archaeopteryx in the middle, the modern crow on the right, and various of these dinosaurs with wing-like structures on the left. And in filling out the evolutionary tree, here we don't need to worry about the detail, but here's just an example to show the kind of study that is now possible because of this rich, rich data set. And one of the things that was going on in the origin of birds was a massive reduction in body size. So reading from left to right, you've got these little silhouettes of beasts, starting with a regular kind of flesh-eating dinosaur at the bottom left, and all the way through to birds at the top right. And all the way along that, that evolutionary sequence, we're seeing a remarkable miniaturization. And so these kinds of long-term, large-scale transitions in evolution can now be studied in a way that Darwin and Huxley would have absolutely loved, I'm sure. And not only the traits, but also the functions. So this study last year drew together information from many, many of these new Chinese fossils to show that actually birds were not the only dinosaurs that evolved flight. So if you look at the evolutionary tree on the right, we have at the bottom in green, so the green ones are those that could fly with so-called powered flight. That means flapping the wings up and down and staying aloft for a continuous amount of time. So of course we have Archaeopteryx and later birds. Clearly they evolved proper flight. But we have a number of other cases, including Microraptor, where flight had originated, and notice, independently. So many of these other groups were solving the powered flight thing in a different way. Here again is Archaeopteryx with its 4 wings. So it was evolving flight independently of Archaeopteryx and the birds. And another weird one here called Shi Yi, which looks almost like a bat. And so it was evolving flight in yet another way. And so all of this together is showing us that in fact powered flight evolved multiple times in these small flesh-eating dinosaurs. And it only stuck, if you like, or it only lasted for a substantial amount of time in the descendants of Archaeopteryx, in other words, the birds. But what's this got to do with the appearance of dinosaurs? Well, you'll already be realizing that the very fact that many dinosaurs had feathers was a bit of a shocker. And that would clearly change the external appearance. You know, if you compare between a naked-skinned reptilian reconstruction versus something covered in feathers, it's obviously going to look different. But more than the possession of feathers, we're actually able to tell the color and the patterns given by the feathers. And this dates from a paper we published 11 years ago, February 2010. You can see from the title, we're talking about melanosomes. I'll explain what they are. They are the key. And we are talking about the color of Cretaceous dinosaurs and birds. And the team of researchers is a bunch of colleagues from Beijing in China, plus a bunch of people from Bristol. And of course, as you can imagine, this created a great stir at the time. And there was a huge amount of press reporting. And not only because we had hit the headlines, but also another group based also in China, but also with colleagues from Yale University in the States. They were hot on our tail. And we didn't realize until the last minute that there was another group racing to get this discovery, We beat them by a few weeks if it matters, but it probably doesn't really. And they were working on a different beast. So here is our Sinosauropteryx, gingery with a nice stripy tail. Here is their Anchiornis with fantastic black and white stripes on the wings and a lovely gingery crest. And to make it really clear, we are saying that, for example, the left-hand illustration is incorrect. We know it to be incorrect. We have evidence to show that. Whereas equally, we have evidence to show that the reconstruction on the right is correct. So there is Sinosauropteryx, all the way back from those early discoveries through to our determination of color. So how do we do it? It's based on melanosomes, and melanosomes are structures embedded within the feather that carry the pigment. So here is a zebra finch, a modern zebra finch, and you'll notice that it's got some quite nice bright colors. And indeed, all of those colors are generated from the pigment melanin. And the pigment melanin in birds occurs typically in two forms. Eumelanin, which gives the blacks, browns, and grays, and all of these colors around the head and the wings and the breast. And pheomelanin, which gives the ginger patch, this wonderful gingery patch on the cheek. And so when you take a feather, such as the one at the bottom, it can carry all these different colors. And in different parts of the feather, when you look in the gingery bits, this is what the melanosomes look like. They're tiny, tiny things. This is 1 micron, which is a millionth of a meter. These photographs are under the scanning electron microscope. And the pheomelanosomes are spherical in shape. And the eumelanosomes are sausage-shaped, as you can see in the lower photograph. So in fact, we apparently have a way of discriminating color based on these ultrastructures within the feather. And they are preserved in the fossils. So here again is that original specimen of Sinosauropteryx. And we took small samples from the surface of these feather-like structures. We looked at them under the scanning electron microscope, whoops, and this is what we saw. And you'll notice, it keeps hopping, you'll notice that there are some spherical structures like here towards the right, and a lot of moldic impressions, so impressions as molds within the matrix of the feather. And referring back to our modern examples, we compare those. They are spherical, so they are like the gingery pheomelanosomes. And we looked all over the body of Sinosauropteryx, and this is all we found. And hence, this is our reconstruction. And we would argue that this is testable and it is scientific. So our declaration about the color and the patterns in Sinosauropteryx is based on fossil evidence. And people could pick holes in this in many different ways. They could, for example, say that we've mucked up the sampling, or we've mucked up the scanning electron microscopy, or that we have mucked up our assumptions of the nature of the relationship between these structures and the color. And so they could go and test it. They could look at a different specimen. They could do the sampling in a different way if they believed we'd done it wrongly. They could look at additional modern birds or modern examples to test whether this relationship is constant. It is indeed constant. It occurs in all birds. It occurs in all mammals. In other words, it occurs in us. If you have black or brown hair, or if you have ginger hair, or perhaps maybe you had hair colors like that in your distant past, they will have been given by these pigments. And if you were fortunate enough to have ginger hair, that means you are very special. You have pheomelanin and pheomelanosomes in your hair. So the fact that this is a relationship across all living vertebrates means that we can confidently apply it to dinosaurs. And there we are. We would say this is testable and scientific just in the same way as repeating a chemistry experiment in the lab or something of the kind. And here is the new reconstruction, which you've already had a sneak preview of. These are the high point of the book. Because Bob Nicholls, the artist, produced 15 original artworks for the book, each of which is based on primary evidence in detail. So we're making a claim that in this book, and here's the cover of the book, In this, and it's not published September, it's published October. In the book, each of the illustrations is not based on imagination or informed guesswork or whatever you want to call it, but each of the illustrations is based on evidence. So this is the first book about ancient life, and it is written for adults, although I've no doubt that many very clever children will buy it and read it. It is intended for adults because it's about the scientific method, it's about the evidence, it's about traveling around China, what it's like in China, debating and negotiating and discussing. But each of the illustrations then is as near as we can make it the real thing. We're not guessing anything. So let's have a look at another story. I've told you about Sinosauropteryx in a bit of detail and about how we can tell color and how we can identify fossil feathers because of their remarkable preservation. Here is another fantastic illustration by Bob Nicholls showing Psittacosaurus. The name you may be able to work out means parrot reptile because of its rather parrot-like beak. Here's a mum and some babies. Look at the color. She doesn't have a lot of feathers except for those weird things on the tail. And they are called feathers. There's some weird kind of feather that this thing had, just as probably as a kind of display structure. But otherwise, as far as we can tell, the body was covered with scales. But notice the different colors. There's a mottled dark brown color over the back, some lovely big brown mottles over the shoulders, and a pale belly under the tail, under the body, and the head has got these very dark brown horns at the side, and so on, and the babies. So how do we know all that? Well, first of all, we know lots about the babies because many of them are preserved in clutches, just like this one here. And this clutch was studied by a student of mine a few years ago, and he was looking at the relative ages of all these little beasts. And it turns out that out of these 6 little creatures, 5 were 2 years old, and 1 of them was 3 years old. And he worked that out by counting the bone rings in the leg bones. And it's the pink one, number 1. That's the 3-year-old mixing with the 2-year-olds. And so we're imagining, this is where we have to guess, of course, we can't prove this. We're imagining this is a little clutch of siblings that maybe hang around together for safety. They're plant eaters, they're quite small. As you can see from the scale bar, they're maybe only, I think this is maybe a 10 centimeter scale. So they're only the size of a small dog, and the parents would be much, much bigger, like a pig. But they're running along, but look, they're all pointing the same way, and actually they're preserved in ash. So they come from a locality called Lujiatun in Liaoning, where unusually there's ash fall, just like at Pompeii. And it seems that the dinosaurs here were trapped under hot ash. But that burnt off any feathers or skin or soft tissues. So the reconstruction that I showed you a moment ago is based on this amazing specimen in the Senckenberg Museum in Frankfurt in Germany. And this is an adult. It's about 2 meters long, and the head is at the right-hand end, and you can see on the tail the traces of these weird reed-like, feather-like things on the tail. But notice the skin pattern. And these colors, the dark and pale colors, are real. They are melanin, which survives in the fossils. And you may remember the speckles over the legs and the shoulder, and there are the speckles in the original specimen. And these were the original reconstructions done by Bob Nicholls in the scientific paper, Jakob Winter and colleagues. Winter is a colleague in Bristol, so this is very much a story of research in Bristol. Although this is world research, we're doing much of it. And there are the beast coming at you in many different directions. And all the color then in these pictures is based on the fossil. And there's the reconstruction, and I just let you feast your eyes on that for a moment, because Bob Nicholls has done wonders in generating these amazing images. And we think, or we'll argue, that this will set a new standard for what dinosaur books have to be like in future. Less guesswork, more evidence. So we've looked at a couple of dinosaurs. Let's have a look at something that's not a dinosaur, but is a pterosaur, a flying reptile. And here's one from the Middle Jurassic of North China, and I had the great pleasure and privilege of working all over China, but also in the localities where these things come from. And it's liberally covered with fur, and these fur-like structures in pterosaurs were traditionally called pycnofibers, because it was assumed that somehow they're different from mammal hair, different from bird feathers. So we had a close look at a couple of specimens from this locality. And we discovered to our amazement that actually the pycnofibers are not all simple bristles. And in the illustrations on the right, we've got photographs and drawings of the pycnofibers. And some of them are simple bristles, but you'll notice some have got a tuft at the end or a tuft halfway down. Whoops, keep jumping. Or some tuft from the bottom. And in fact, these 4 types of pycnofibers are all found in either modern birds or in dinosaurs. So in our 2019 paper, which again is a group of Chinese colleagues, as well as a group of Bristol colleagues and colleagues from elsewhere, we are now claiming that these structures are feathers. We call them integumentary structures with complex feather-like branching. Well, you have to be careful when you write. You've got to be conservative when you write the scientific paper, but we are saying they're feathers. And because they contain melanosomes, we can identify the colors. And here is Bob Nicholls' reconstruction of this happy-looking little pterosaur. It's quite small, about the size of a pigeon. And you can see a nice big grin on his face because he just spotted that rather juicy lacewing, which he's going to grab. And let's have a look at another pterosaur. This is a later one from the Cretaceous, when they got a lot bigger. And this one is completely mad in appearance, Tupandactylus. This one is from Brazil, where quite complete specimens have been found, some of them even with soft tissue. And to orient you, in this museum specimen, the head is this huge thing at the front. And you'll notice it's got this long, thin strut, like this, the rising edge of a sail at the front. And then the back of the skull extends back a long way. And it's full of openings because it's very lightweight. This is a flying animal. So it seems mad that it has such a huge head and yet such a lightweight head. And to orient you on the rest of the body, these are the wings folded down, and it's got little hands so it can walk on the tip of its wings, and then the legs at the back. And let's look at this skull in a bit more detail. So here it is, and indeed the membrane that is supported between the 2 struts behind the skull is preserved in this specimen. And on close study, it turns out to be full of melanosomes, which enable you to identify color patterns, a speckled color pattern as shown here. And it's even been suggested that some of these pale colored speckles might even have been photoluminescent, meaning that they pick up sunlight energy during the day, and then they radiate that energy after dark, just like a glowworm. And so that these things would not only be showing colorful crests that they might have used in sexual display, just like birds displaying to each other, but they could have even added a bit of flashing at night. And here is Bob Nicholls' reconstruction, showing that speckled pattern over the head and indeed potentially over the wings as well. So my final story is a more traditional looking dinosaur, a big one. This one is from Canada. So this is to show you, although a lot of the wonderful things come from China, there are wonderful new dinosaurs from other parts of the world which preserve color. And the Athabasca tar sands are huge. And as the name suggests, they are sands full of tar. They're scraped up in northern Alberta by the millions of tons, and they're boiled to extract the oil. But in 2011, a huge dinosaur skeleton weighing about 10 tons was excavated by my former student, Don Henderson, who happens to be the director of dinosaur studies at the Royal Tyrrell Museum in Drumheller. And this is it after a huge amount of cleaning up, because it took a lot of effort to remove the rock and clean down to the fossil itself. And the head is at the right-hand end, and there are these vicious-looking spined armor plates over the neck region and over much of the body. Notice the little person up at the back, just to give you an idea of the size. This was described in 2017 with a number of diagrams to illustrate the complexity of the armor cover. And indeed, you can see in the fossil at the top, particularly at the right-hand end, they all look quite gingery. And indeed, there's a lot of pheomelanin preserved in the covering of the bony plates. So what we're looking at here are bony plates, in other words, plates made of bone, just like in the skin of a crocodile today. But just as in a crocodile, you don't see the naked bone on the surface. They are covered with keratin. They're covered with the protein keratin, which is the same protein that makes feathers and hairs and our fingernails and the horn of a deer or the horn of a cow. They're all made of keratin. And here's Bob Nicholls' reconstruction. Now, this is a dinosaur. This is a real dinosaur. And you can see the astonishing armor that this thing had. Indeed, it weighs about 5 or 6 tons in life. It's huge. It's as big as a tank. And it would protect itself by hunkering down. But if the predator got a bit more frisky, then Borealopelta, northern armored beast, would swing its great scimitars, and those long ones over the shoulders are about 1 meter in length. And so talk about Boudica and the blades that she supposedly had on the wheels of her chariot. There's nothing new under the sun at all. So I'm just going to wrap up now by stressing the fact that as a paleontologist, I've been massively favored by 2 big things. One, astonishing new fossils, including from China, exceptional fossils. And secondly, real advances in the methods that we can use to determine a lot about the life of the dinosaurs. So if you thought before I began speaking that knowing what dinosaurs looked like and how they behaved was all guesswork, let me tell you, it is not. And I've shown you how we've determined color, and that's a testable, those are testable hypotheses. And we describe in the book all of the evidence and the ingenuity that people have put towards that. But we can also determine these other things: speed, bite force, feeding style, growth rate. These are all based on evidence. I'll just touch on a couple very briefly before I wrap up. So we can indeed determine the mode of locomotion and the speed of dinosaurs from thousands of fossilized trackways. Some of you may have seen such things, particularly, for example, on the Isle of Wight. And it's a well-known fact that the spacing of footprints, the stride length, is proportional to speed. So you can calculate the speed of movement. You can also calculate the speed of movement by reconstructing the musculature. And this, I'm really not describing this in any detail, but the reconstructed musculature, which is proportional to the thickness of the bones, tells you something about speed. Because if you've got massive leg muscles, you can run faster than something that has rather weedy leg muscles. And biting is the same. We have double evidence here. We have, for example, on the left, dinosaur bones that have been bitten by T-Rex, and you can use the depth of the bite to calculate the force that was applied to drive the tooth into the bone. But you can also do this by computer modeling. So there's a wonderful 3D image of the skull of T-Rex and with reconstructed muscles. And you can use this to calculate enormous bite forces in T-Rex, much greater than in the great white shark or the lion. And why do we believe this? What makes us believe that these calculations are in any way meaningful? Well, the fact is we repeat the calculations for living animals. So you can take a scan of a human skull or a lion skull or a great white shark skull, do the calculations, and indeed it gets the right answers. And we know that these methods work. This is Emily Rayfield, who's my colleague in Bristol, and she has pioneered through her research career the use of finite element analysis, which is an engineering technique that's been long established and is a great way of calculating the behavior of complex 3-dimensional structures, which are modeled in the computer. So of course, when you read about aircraft engineers or car engineers, bridge designers, building designers, how do they do their designing? How do they work out the lightweight materials that they can safely use to build an aircraft, for example? It's all done using FEA. And so if you go on an aeroplane and trust that it's not going to crumple and fall out of the sky, you trust that FEA works. And therefore we trust that it works for T-Rex as well. And so wrapping up then, the book is 15 stories, each given with a great deal of illustration of the human side, who did it, and these wonderful professors around the world and students in many countries, and all the fascinating new work they've been doing, as well as these astonishing new fossils. And the theme behind it all is the transformation of paleontology into very much a scientific discipline. But I've tried to illustrate this, of course, in a lively and engaging way. So there you are, the book is there, and I think William said that there will be a link so that if any of you are minded to have a look at a copy or purchase a copy, I'm sure you'll be able to do that. So I'll stop now and I'll be very happy to entertain any questions. So thank you for your attention.
Thank you very much, Mike, for not just a fascinating talk, but delivered with such infectious enthusiasm and conveying some of the excitement of how a subject that's 150 years old still has frantic races to get to publish first on some of the new findings.
It doesn't often happen, I have to say.
But still finding so much new stuff to be excited about.
That's right.
And who wouldn't want the young dinosaur enthusiasts in their family to be the best informed in the entire school? And Christmas is coming up. To add to that, our local bookseller, P&G Wells, have very generously offered a very short-term discount if you use the link and the code that's in the chat. So do please hurry along, and we know you're buying it for yourself, really, but you can justify it because you're going to give it as a Christmas present. So, right. and you can read it to them, and they can read it to you. And so let's get lots of questions into the chat. Just a quick heads up, our next talk is on Monday, the 6th of December, with now Professor Oscar Diaz from the Southampton Stag Cosmology Group. He gave us a talk about 3 or 4 years ago when he was Dr. Oscar, but he's now a professor, and he did give one of the most fascinating and accessible talks on cosmology we've ever had. Lots of people were really enthused about that afterwards. He hasn't actually told me what it's going to be about yet, but it's probably black hole related because that's his specialist area. So yeah, do get the questions coming, and you happy that we go straight on to that, Mike, rather than...
Yes, by all means, I can read the question if you like, or would you prefer?
No, I'll sort of where people are reading about it once we get them in. And in fact, I have one of my own, which I was going to start off with. Iridescence. Is there any evidence? Could there be any evidence?
The answer is yes and yes. So I didn't talk about iridescence in the talk, but a couple of the dinosaurs in the book indeed are postulated to have had iridescent feathers. And so to remind people, iridescence is the kind of super reflection that you get in certain structures where there are multiple layers that partly transmit light and partly reflect light. And in birds, we famously see it in the kingfisher, of course. If you're fortunate enough on a sunny day to be looking over a river and a kingfisher goes by, the flash as it turns in the sun is impressive. And so many birds have iridescence. And the way it's achieved, indeed, is by alignment of the melanosomes. So the way that the physical sheet-like structure is generated inside the feathers of a kingfisher or other iridescent bird is by alignment of the melanosomes. And so that's something that can be seen in the fossils, and indeed some dinosaurs have it. And so as far as we know, though, they also had color. The kingfisher, interestingly, of course, I don't know if anybody has tried the experiment of putting a kingfisher in the fridge, and you shut the door so the light goes out, and then you just peek in. What color is the kingfisher at night is a question I ask my students, and it's certainly not blue, because obviously the blue is a reflection of the sky, isn't it? And so the blue is a non-color in terms of pigment. And so many dinosaurs have that feature as well, it seems. And the iridescence of beetles, which is even more startling, many of you will know that's made of multiple layers within the cuticle of the elytra, so the hard shelly structure of the back of the beetle, may be made of 8 or 10 thin layers, and that gives that. And that is usually underlain by actual pigments, so orange or green, with that layering, and that's why some of these tropical beetles have that astonishing flash of color. So yeah, dinosaurs had it too, and we can tell it because the fossils show it, which is great.
Cool. The one of the images you showed was of a green dinosaur. Would that be pigment or iridescence?
It's green, you say?
I think, yeah, one of your, I think it was one of the first images you showed.
Oh, that was an erroneous illustration. So the point was, I should have mentioned en passant, that the early illustrations of Sinosauropteryx were pure guesswork, and we now reject all of those.
Okay.
But nonetheless, that raises the point, certain birds do have green and yellow and other colors. So the color of hair in humans and mammals is purely based on those two kinds of melanin. But in birds, you have melanin colors and others. So if you think of a flamingo, the color is derived from its diet. Famously, if you don't feed the flamingo the correct food, it goes off color. I don't think it's so true with all diet-derived colors. So if you think of a mallard duck, it has rich green and purple, and those come from porphyrins, which come from the diet. But I think it's quite, I've never heard of an experiment where somebody has somehow denied a mallard the correct diet, and somehow it goes very peely-wally. Whereas flamingos do go off color because of the red microorganisms that they feed on in the salt lakes. And so we cannot yet detect those diet-derived colors in dinosaurs. They may have had them, they may not have, we just don't know. So carotenes are the yellows and reds, and porphyrins are the greens and purples, but mammals don't have those, so we just have melanins.
Watch this space.
Yeah, we should be able to soon.
David Kay has asked, did any of these have flapping flight?
Yes, so definitely. I think I showed the diagram of the origins of flight, and all of those had flapping flight. Microraptor flapped all 4 of its wings. Chi-Yi flapped its leathery wings. And so all of those 4 or 5 different lines of small theropods, including the ancestors of Archaeopteryx, they were all capable of flight, flapping their wings, muscular muscles on the breastbone, and it's just that they didn't go far. You know, no, let me reword that. In evolutionary terms, they didn't give rise to a great number of others, but they were flying around perfectly well, and birds succeeded. So that's the key thing. That these are shocking new discoveries that people would have denied a few years ago.
And Cleo's asked, will they still be offering the discount on Saturday? I don't know is the short answer. It was originally applicable up until today, and they agreed to carry it on for a few more days. I know they have an evening event there on Saturday, which is probably what Cleo's talking about. In fact, as people were asking about our own live events, we did briefly explore the possibility, as Mike had indicated, a willingness to travel, whether Wells could in fact host this talk for a rather smaller audience than we would normally have live. Unfortunately, they had a prior event on that evening, and it wasn't going to work to try and pursue that, unfortunately, but hopefully we will do in future. So when Mike brings out his next book about different diet-based pigments in the latest discoveries, then we hopefully be able to do that one live.
That'd be lovely.
Cleo's also asked, is it only theropod dinosaurs which have feathers, and how early were the first proto-feathers?
So I didn't have time to talk about that. Again, there's more in the book, but in fact, we're pretty sure that feathers go to the root of dinosaurs, so that they all had feathers or the potential to have feathers. The armored dinosaurs probably lost their feathers, and the true giants, the sort of brontosauruses, probably didn't have feathers either. And it's a little bit like mammals that we know, of course, elephants and whales are mammals, but equally they don't have a lot of hair. Maybe the babies do. You think of a baby pig, it's very hairy, it's like a little puppy. And then it loses its hair as they get bigger and fatter. They don't need the insulation. So I suspect there's a bit of that. And we trace it to the root of dinosaurs. And indeed, if pterosaurs have got feathers as well, then it goes even deeper in evolutionary terms.
I was going to say, what came, if all dinosaurs potentially had feathers, what came before them?
Well, so pterosaurs are close relatives of dinosaurs, so they share a common ancestor that we don't know. We know roughly when it lived. And before the dinosaurs, there were common ancestors of crocodiles and dinosaurs, and there were mammal-like reptiles and a whole diversity of other creatures, but probably that were not warm-blooded. So I think there was a whole phase of evolution of warm-bloodedness in the Triassic, and that was important in the origins of mammals, i.e. us, and the origins of birds and dinosaurs. And these were all kind of evolving side by side at the same time and getting warm-blooded, I think.
Okay, and Marina has asked on YouTube, which recent discovery has changed paleontology the most?
Well, I think the Chinese feathered dinosaurs, of course, have made a very strong case there. It's not just the appearance, it's stuff like origin flight and other big unexpected discoveries like that. I suppose the other major recent discoveries, I mean, you'd like to point to some human fossils, but actually in the last 20 years, there's not been any massively shocking discoveries. Maybe I guess the biggest have been the Denisovans, found in Georgia and some other parts of the world, and now they can be genetically coded. We can sequence their DNA, and it turns out the mixing of Neanderthals, modern humans, and Denisovans is really quite complex. And I suppose the other fossils that have been very important also from China have been early animals. So from the Changjiang Formation, something like 500 million years ago. Some of you may have heard of the Burgess Shale of Canada, Cambrian in age, and that preserved the earliest vertebrates and the earliest of lots of other animals. But the Changjiang fauna is another 30 or 40 million years older. And so it takes us even further down towards the roots of all the different animal groups, like the oldest mollusk, the oldest arthropod, the oldest vertebrate, that kind of thing. So some of them are pretty important as well.
Oh. Kirsten said, lovely talk and pictures. Will the link for the book be posted after the talk? Well, I've put it in the chat twice. It was also in the email I sent out. So hopefully people can find it from that. Otherwise, just ring up Wells and ask if you can have the Cafe Psi discount on it. Mike said, did I understand correctly that the evolution of birds was quite rapid about 100 million years ago? Do we know what drove that?
So in fact, the evolution of birds was not rapid. It lasted for much of the evolution of dinosaurs, because what we now know, so until the Chinese discoveries, people often looked at Archaeopteryx, and you can find some wonderful creationist websites which still give the old story that they believe to be true, that Archaeopteryx just hatched from a crocodile egg. And so they love to talk about that, you know, birds just evolved like that. And so now, of course, we have, as I mentioned before, 50 feathered dinosaurs, and they tell a story of the origin of birds over about 50 million years, 50. So that is very gentle, very gradual, very slow evolution, not rapid at all. And all of these little dinosaurs were diversifying and becoming smaller, and all of them with feathers already, with hollow bones, climbing in trees, many of them leaping around and gliding, and then a number of them independently evolving, flapping flights. So we've got a wonderfully rich and slow and gradual evolution of birds.
Okay, thanks. Bob Whitmarsh, do you want to unmute and ask your question yourself? Because I'm not quite sure which bit you're putting the emphasis on there. You can explain it better.
Well, okay, these dinosaurs could fly. My question is, how far could they spread? I mean, is there any evidence they could fly over water, for example?
Oh, I see. Yes, yes. So geographically, yes, I imagine they could spread quite far, but unfortunately, so we have them in numerous localities across China. So I suppose that shows that certain individual species were distributed over maybe 2,000 or 3,000 kilometers. But beyond that, we just don't know. We don't have appropriate fossil deposits in other. Well, there's some in Spain about the same age, and they have different species. So it may well be that these different early dinosaurs and birds were sort of restricted to their own continents, a bit like today.
So that timing was after the continents had drifted apart.
Well, yeah, they were kind of moving apart in the Cretaceous, and sea levels were rising, so that caused oceans between them. So yeah, they were beginning to split apart. You're quite right that you're reflecting the fact that when dinosaurs originated, there was a single supercontinent, Pangaea, and there was not the sort of climatic, extreme climate variation we get today. So a lot of the dinosaurs could toddle around all over the world. I think by the middle of the Cretaceous, when these things were around, the continents were splitting up a bit.
So we were just beginning to need to be able to travel a bit further and over water.
Yes.
Christine said, excellent talk. What was the function of the huge crests on the pterosaurs? Did both males and females have them?
Completely bonkers. People thought for a long time that the crests must just be with the males because they're so stupid. I mean, the crests, and in birds today, the males may be encumbered, like think of the male peacock, they may be encumbered by some enormously crazy structure. And it was indeed Charles Darwin who worked it out. It's what he calls sexual selection, which can be opposed by natural selection in certain cases. So the male peacock takes enormous risks because it's got to carry this bloody great tail around all the time. And of course, that makes it more easy meat for predators who can see it a mile away. And just to fly around with that great tail is quite an effort. But the idea of sexual selection is that male with the crazy big tail, if it can win more female mates and mate more, it doesn't matter about the natural selection thing. The sexual selection thing will outweigh it. And so, but then the thing is, amongst the pterosaurs, they all seem to have the crests. We don't find examples of the same species with and without the crests. So it's that kind of sexual dimorphism where the males maybe were bigger or more brightly colored, but both males and females, it's like certain deer today, both males and females have the horns or the antlers in certain cases. In other cases, they do not. And so it seems in this case that they may have been sexually dimorphic, but both males and females had to carry the encumbrance with them.
Couldn't have been that they actually used it like a sail to kind of be able to get some extra propulsion from.
No. People have done wind tunnel experiments with models, including at Southampton, where there's a very good aircraft type wind tunnel. And in fact, the difference in steering and airflow is negligible in a way. So in a way that says you can have a crest in these ways and it doesn't matter. And therefore we can say it's probably nothing to do with aerodynamics, but must be sexual selection in some way.
Fascinating, especially if the had the potential to be luminous and glow in the dark.
Completely bonkers. I know.
Again, I mean, that kind of argues very much for some sort of sexual selection, because otherwise it's potentially a predator.
Dangerous. Yeah, come and look at me. Flash, flash. Come and eat me. Flash, flash. I know, not very sensible.
Yeah. Well, I think that's got through all the questions we have. Thank you once again. It's a brilliant talk and delivered with such passion and enthusiasm and excitement. Wells have got a stock of the books in for us specially, so please don't disappoint them. And we will be back on Monday, the 6th of December. And Professor Mike Benton, thank you very much again.
Thank you, William, and thank you, everybody. Bye.
Thank you.
Bye.
Bye.